Welcome to Papa Junk Shop. You know, it's a nice dripping cold day, so thought we'd spend the day in the shop. Got the heater fired up, probably hear it in the background. And we got, I think it's called an Alpha pure sine wave inverter that one of the Amazon people asked me to check out for them. So let's take a look at it. Run her through some tests, see what we think of it. 1500 watts supposedly, 12 volt, pure sine wave, and the box feels pretty heavy, so it must be a relatively decent one. Okay, we got a little bit of paperwork here. It's pretty simple. Got some of that good tough packing, so she should be in good shape. Wow, pretty good size compared to my supposedly 1600 watt one. Got a couple of fans. Pretty beefy looking posts, although I don't really care for this type of connection. I'd rather have just a hex one you can put a wrench on. Well, I don't see any bolts for MOSFETs and stuff on the side, so that's good. So the case isn't the main heatsink. I like that. Okay, we got two plugs, and we got volts and amps. I assume that's AC. This must be DC volts. On off. A couple of USBs. Indicator light. Alright, well, let's just give it a quick look-see on the power supply to start us out. We'll see where it drops out, low voltage and high voltage, and see what the display looks like. I'll get that hooked up and be right back. Okay, hopefully you guys can see everything okay. Got the power supply out here. Tipped up so you can see, hopefully. So, got the power supply hooked up, set it for 13.3. That's about like the lithium iron phosphate battery you start out at, probably. So let's turn it on and see what happens. Tell the power supply to come on. Okay, now we got 13.3, same as the power supply says. 113 volts, no load. It shows no load. Looks like the idle consumption is about 0.3 amps. Pretty decent. Let's see, I got a little 40 watt bulb here. Just plug that in, see what that looks like. Okay. You know, not enough to register on the amp meter, but got 109 volts. This says 12.9. That could be because these wires on the power supply are really light, so we're going to do some real load testing. I got two 100 ampere hours paralleled up here when I go to load her up, so this is just a quick look here. So, okay, let's see. I got a flashlight here I've been using quite a bit. It charges with USB, so let's try the USB part. Not going to measure the current or anything, just see if they work. I'm sure that the USB ports aren't a big deal for most people, but we just want to make sure they work. Yep. We got a red light here. Hopefully you guys can see it. Throw the charging on that one. And the same on that one. So both ports work. So let's see where she shuts down at. Let's lower the voltage here. 12.3, 11.3. Okay, let's go with a little bit of 5 here. 9.5 is supposed to start beeping, or 10.5 I mean, and that's what it says over here. So I guess we better go by this one because of these wires. At 10 it should shut down. Okay, there's 10. Yep, shuts down, we got a red light. Okay, let's turn it back up and see if it comes back on its own. Or if we have to shut it down to reset it. Looks like we're going to need it. Nope, come back. Okay, let's go the other way now and see. We'll bump her up. That's 14.75. We'll go from there. We'll go by this one again. So she shuts down, high and low voltage, just like it should. And it comes back on its own when the voltage gets back in range. Okay, let's see, we can take a look at, let's look at the output waveform, see what that looks like. Should have had this ready, shouldn't I? Let's see. Okay, we got a nice sine wave. You guys see that? See, I haven't run this thing enough to know. Let's see, range. Make it worse instead of better. Oh, that was too big. Well, looks like a decent sine wave, so that's not an issue. So, I'm going to shut this down. Before I hook it up to some batteries, here's the back. And I think these are the same as what goes in the batteries, M8. So they're good, healthy connections. I just wish they didn't have these plastic kind of things, just had a regular nut on it, which is no big deal. You can get one and change it. It does come with a lock washer and a flat washer, so okay, we'll get her hooked up and put a load on her and test her out good. Okay, I'm going to do my testing a little different today. I'll show you what we got going here. I got two 100 ampere hour Gens batteries parallel So we got 200 ampere hours available there. So we shouldn't have any problem with not having enough current. I got my DC monitoring here. I'll have my AC monitoring here. And I went in the house and took the induction cooktop off the counter that we use every day, off of my hybrid inverter. So I thought we'd give this a real try. And I've got, now let's turn it on. Okay. I'm going to start us out on 600 watts, and I've got a pan full of ice cold water, and we'll put it on medium, and we'll push the start. Okay, there we go. So we're showing what, 5 amps here, 111 volts, showing 12.8 volts at the inverter. At the battery, we're showing 13.1. Now, for my hookup, this is number 2 here going into this monitoring. And from here, this inverter doesn't come with any cables, which even the chintzy ones that I've gotten always come with cables, even though they're not very good, but at least there's something there. So these are ones that come with my Sine 2000 watt inverter, which I don't use because I got it permanently installed in the camper. But so I use those. Those are pretty decent heavy cables, so they should be adequate. So let's bump it up to 900 watts. So we went up to 6.9 amps, 111 volts. Let me see. Oh, this is upside down, isn't it? Okay, let's turn it over. We're showing 6.9 here, showing 7 amps there. 110 volts here, says 111 there. 773 watts. Okay, so let's bump it up to 1300 watts. Didn't make a lot of difference. We'll put her up on max. Okay. Probably because that pan isn't covering the whole burner, so that's probably maxed out. So I'm going to let that run for a little while, and we'll grab something else to add on to the load. Be right back. We've been running for about 3 minutes. Still don't have any fans on. Thing is still cool. So I have a 750 watt incandescent light bulb. Let's throw that on there. Okay, we're up to 11.1 amps, 1417 watts. So that's pretty close to max. So let's let her run for a while there. Okay, it's been a few minutes. We're still at 1442. 13.3 amps it says here, 12.8 over here. Still at 111 volts. I was checking some of the cables, and the ones going to the inverter are just lukewarm, and as you can see, we're drawing 146 amps here at 12.3 volts. And we've used, well, getting close to 9 ampere hours. Water's starting to steam a little. Let her run for a bit more. No, still no fans. Okay, it's been 7 minutes. The fans just kicked on. And it's blowing air out the front, which is surprising. Usually the air goes out the back, but let her run for a bit. I'll check back in. I turned the light off. I kind of forgot that that's a 100 amp shunt on there. We were running 140 some amps through it. It got a little bit warm. I was thinking I got a 350 amp shunt on my system, and I was thinking that was the same, but it's not. So I shut the light bulb off. So we're back down to 381 watts. And we'll see when this fan shuts down again. It's blowing some relatively warm air out of there. Okay, the fan ran for about another minute. Now I turned this back down, and I wanted to see how it acts because I know this thing cycles on and off, and I kind of wanted to see how steady it stayed with a changing load. You know, it's doing all right. So, next thing I'd like to try is I'm out in my garage here, and I have a grinder, half horsepower, you know, bench grinder, that even on my big hybrid system, it complains when I turn it on. I mean, it runs it all right, but the startup is pretty wicked on it. So I'm going to plug that in, and we're going to give it a try. So, got it on an extension cord, and I got it turned on, so when I plug it in, she should try to go. See what it does. Oh, it shut down. Let's try it again. Let me turn the... Okay, it keeps trying. Let's just see what happens. There it goes. It made like 3 tries and it did start it. See, it doesn't draw that much, 4.6 amps once it gets going, but the startup on it is ridiculous. So we're really more or less testing out the safety features on it, and they seem to work. So let's boil some water for a while yet. I'm going to let her go for a while just to see what happens. I'll let you guys know if I run any snags. Try some more inductive motors with this induction cooktop running. What, 6.9 amps? I've got a couple of belt sanders and a drill press here. Let's see. Oops, wrong way. I guess I'm already out as far as I go. Let's turn this one on. Okay, no problem. No problem. Didn't like the third one. Oh, they come back on. There they go. Come back on by itself. So what are we using? 8.3 amps. Of course, they're not doing any work. Pretty impressive little inverter. The fans don't come on that often. You know, they come on when we hit her right up to almost max, but when it's drawing 6-7 amps, they come on occasionally for a short time. We've been running for what, 24 minutes, so it's a pretty good test. So I think I'll shut her down and we'll open her up and take a look at the insides. Well, I took 4 screws out, 2 there and 2 there, see if this top comes off. No. They got 4 screws. That's more than any of the other inverters I ever took apart, so let me get those 4 out. Okay, so I got the other 4 out. Here we go. Alright, there we go. So it's nice, they got dedicated heat sinks. These transformers are pretty tall too. So the fans are relatively small, but they seem to work well. We got not sure, I would guess it's probably number 10, just a guess. There's some writing on there. Can't quite make out what it says though. Irregardless, it seems to work well. Everything looks nicely laid out. These capacitors are all stuck down nice with some type of silicone. The fans plug in, they're not wired, not hardwired in. It looks like we have a pair of 40 amp fuses right at the end of each one of these transformers. So there's 2 there, 2 there, 2 there. They do appear to be soldered in, I believe. Which is good because you don't have to worry about losing connections, but then if you got to change them, it kind of turns into a hassle. Overall, the build quality looks good. Every connection has got silicone stuff on it to secure it. You know, so I can't really find anything much to complain about this thing except for these terminal nuts, and you know, that's not really a big deal. Don't let that stop you from getting one. You can go to the store and buy a couple of nuts for a buck and use a wrench. But you know, I put this one to the test more than I have any of the other ones that I've bought, and it seemed to do well. I mean, how many times did it shut down and come back on, and you know, never heard it. So all the protection stuff works really well. Some of the chintzier ones that I've done, you know, how it shuts down, it blows the fuses in them. So this one seems to work really well. I would recommend it. And there'll be a link down in the description, you know, if you guys want to buy one of these. I wouldn't have any qualms about buying one. I think you'll be happy. So, you know, the instructions don't amount to much, but you know, what instructions do you really need? You know, if you guys want to see the specs, you can stop the the video there and look. I'm not going to read them off to you, but it just seemed to do what they said it would do. No problems. So if you enjoyed this one, you know, give me a thumbs up, and if you haven't subscribed, please do. And hopefully we'll have more stuff like this to look at. Like I say, I don't get anything out of this except this inverter, so see you next time. Thanks for watching.